Okay, so Jaden, did you attempt the homework or no?
I cannot find it.
Oh, it was on page 200. Yeah. You find it now or not?
Just now. Right. Have it. It's 200, yeah.
Alright, so let's go. I don't anticipate you being able to answer every single question here, but we'll see how it goes. Do you remember how to combine resistors in series and parallel?
Yes, sir.
Okay, good. That's the foundation. Vani, I don't think you'd know how to do that, but you'll learn as we go along. Alright? Okay, so I want to do this question with Vani, seeing that she's kind of new to this. So Vani, give this question a read for me.
Calculate the reading on the 1 ammeter and 2 volt.
Okay. So, Vani, do you know what the main things are in a circuit, like what you measure? Tell me, Vani, do you know what are the main measurements you take first in a circuit?
The voltage,
The voltage and the... It's not just the voltage, it's the voltage and something else.
the current.
Right, the voltage and the current. So you see this A over here? This is called an ammeter. And what do you think it measures?
Current,
Right, that measures current. And it's placed in what in the circuit? Look at the configuration. Do you think that's in series or parallel? Are you not sure?
parallel,
Nah, that's in series. So okay, if a component is hooked up in series, then it you just put it in the circuit. You don't like let me explain. So there's something called there's something called conventional flow of current, and it says that current flows from positive to negative. So if I draw in the current, which goes from the positive, which is the longer terminal for the battery, to the negative, notice that the same current goes through the ammeter. It's the same current that goes through the 8 ohm. Now, let me ask you a question. At any point here, did the current split?
no sir,
It didn't split yet. When it reaches this junction over here, what's gonna happen?
it was split.
It will split. Then at this junction, it'll meet back and it'll return to the negative. Now, if the same current is going through a component consecutively, it's series. If at any point the current splits at a junction, chances are those components are parallel to each other. So the ammeter is always hooked up in series. This, however, is a voltmeter. And what do you think a voltmeter measures?
Voltage,
Right, and you can think of voltage as the difference, the potential difference between 2 points. Between 2 points. And I'm saying that because it's very important. Over here, we're measuring the voltage across the 10 ohm resistor. So I need to place the voltmeter before the resistor and after the resistor to find the voltage drop across it. So voltage is always between 2 points. That's why I placed the voltmeter in this manner. Do you think I hooked up the voltmeter in series or parallel? Parallel, yes, that's parallel. Because the current split at this junction. Just to give you a quick crash course, if you want to combine resistors in series, then it's just R1 plus R2, so on and so forth. It's really simple. You just add the consecutive resistors. If you want to combine resistors that are in parallel, it's open bracket 1 over R1 plus 1 over R2, so on and so forth, plus dot 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 to the power -1. Now in this question, they want us to calculate the reading on the ammeter. Now let me ask you guys something. The current going through the ammeter, is that the total current going through the ammeter, or like some amount of current? Somebody tell me. Jadon, Vani, Drew, Kestrel.
The total current.
Exactly, the total current. The current never split yet. So that current that's going through the ammeter is the total current. So anytime you have to find the total current, you first have to find the total resistance. So let me ask you all a question. Should the ammeter and the voltmeter affect the circuit?
No.
No, it should not affect the circuit. So I want you to forget about the ammeter and the voltmeter for now and just redraw your circuit. Because we understand that the voltmeter and the ammeter should not affect the circuit. And how do we go about doing this? Well, the ammeter should have a high resistance or a low resistance.
Low resistance.
Algae don't know he work, right? Low resistance. Because you would want the current to pass through without dropping a voltage. And the voltmeter would have a high resistance or low resistance?
Low resistance.
No, very high. Very high resistance. Do you know why? Looked at how it's configured. What happens at this point? What happens at that point? What's happening to the current?
It passing.
What's happening to it? Passing is not a good word to use. That's what S. So it was one continuous flow of current, and when it reached junction, it what?
It's split.
Right. I don't want the voltmeter to use up any current. I don't want it to pull any current from the 10 ohm resistor. I don't want it to affect the circuit. If I have a high resistance here, where will most of the current pass through?
The 10 ohms.
Exactly so. If you have a voltmeter in a circuit, you want a very, very high resistance to prevent current from passing through that component. Ideally, you want the current to pass through the component you're measuring, not the voltmeter. So the voltmeter should have a very high resistance because you don't want any current to flow through your voltmeter. Okay? Nice. So the first thing we're going to do is we're going to consider our circuit without the voltmeter and the ammeter. So Vani, I'm going to ignore the ammeter and the voltmeter for now. So I have an 8 ohm resistor there, and then I have a 10 ohm resistor. Vani, do you think that these resistors are in series or parallel?
Series?
Right. When you're watching Netflix and thing, and you just watch one episode after another episode?
Yes, sir.
Exactly. And so when you look at the circuit and just have one resistor after another resistor,
Yes, sir.
I mean, it's a series, right? They're connected in series. So the path of current is going to look like this. Guys, is the current splitting anywhere, or is it just one continuous path for current to flow?
One continuous path.
Continuous.
Yeah, one continuous path. So therefore, these resistors are in series. So you have an 8 ohm and a 10 ohm. So if I wanted to combine these resistors to find the total resistance RT, what would I do?
Add them.
Add it.
I would literally just say 8 plus 10, and that would be what?
18.
Right, that would be 18 ohms. So my circuit is now going to be reduced to just one big resistor. So that's going to be the equivalent circuit. Right? So it's going to look like this. Oh, what, rain falling. Anybody who in bed, they're gonna fall asleep even more. Hey boy. Hey, this is nice weather to sleep, you know. This is nice weather to sleep. It was tough for me to get off bed this morning. Real tough. So I know how it be. Alright. So Vani, do you understand that we combine the resistors? So now I could just draw one circuit with one big resistor that's equivalent to the two smaller ones. I don't know if you understand that.
Yes.
Alright, nice. So I have a question for you all. The question wanted us to find the reading on the ammeter, and we said that was the total current. So if you look at the circuit, the voltage was provided to us. So the voltage of the battery is 1.5 volts. And we have the total resistance. So tell me guys, if I have the voltage and I have the resistance and I want to find current, what formula should I use?
I equal V over R.
Right, and that comes from what formula? What formula does that come from? Ohm's law. So Ohm's law is typically V is equal to IR. And so Vani, notice that we have V, we have R, and we're trying to find for I. So what will we have to make the subject of the formula here? Tell me Vani.
I.
We have to make I the subject of the formula. How am I going to do that?
I is equal to V over R.
Right, so I'd have to divide by R on both sides. What is the voltage?
1.5.
And what's the resistance?
18.
18. So plug that into your calculator and let me know the current, the total current in the circuit.
Zero point zero eight three two.
0.0833. That's what you got?
Yes.
Now in physics we typically write our answer to two decimal places. If you wrote 0.08, that's fine. Alright, so the reading on the ammeter is 0.08 amps. Nice. So let's summarize. Anytime they ask you to find the total current or current in general for a circuit, you first have to combine all the resistors and find the total current. If you want to find the total current, you need to find the total resistance. Alright, here what I was saying, if they ask you to find current, you need to combine all the resistors to make this most simple equivalent circuit. Okay, let's move on. So now they want us to find the reading on the voltmeter. So this was the answer for part 1. So the reading on the ammeter is going to be 0.08 amps. So in part 2 now, they want us to find the reading on the voltmeter. And this one is fairly straightforward. I promise. So I'm going to ask you all, what is the current that's flowing in this circuit? Could anybody remind me? What's the current flowing in this circuit? The 0.08, right? Now hear what, right? This might confuse some people. You might be tempted to say that the current splits here, and it does, but we're gonna ignore it. Why? Because a voltmeter has a very high what? What does a voltmeter have?
Resistance.
Has a very high resistance. So we're gonna ignore the voltmeter, the current splitting there because of the high resistance of the voltmeter. So the current in the circuit, so you see all those arrows, that current is going to be 0.08. So I have a question for you all. Look at where the voltmeter is situated. It's situated before and after the 10 ohm resistor. So we want to find the voltage drop across the 10 ohm resistor. So remind me guys, what current is passing through that 10 ohm resistor?
Open
0.08. So what formula could I use to find the voltage across this resistor? Is there any formula you all could think of? So think of it. I have resistance here, I have current here, and I want to find voltage. What formula comes to mind?
plus IR.
V is equal to IR.
V is equal to IR. Yes. So the current that's flowing through the 10 ohm resistor, we should use the exact number, right? So the exact number was 1.5 over 18. That was the exact value. So 1.5 over 18. That's the exact current, right? And what is the resistance that the current is flowing through? 10. So I want you to plug that into your calculator and let me know what the voltage is.
Zero point 0.83.
Yeah, 0.83 watts. That's how many units. 0.83 watts.
Volts.
Volts. Right, because we're measuring voltage. So here what? I'm going to change up the question a little bit. What if I place the voltmeter by the other component? Let's see if y'all will be able to answer that. So what if I took the voltmeter and I placed it across the 8 ohm resistor? Yeah, so let's say for a second I took the voltmeter and I placed it over here. Let me see, I'm gonna give you all 2 minutes. Go. 2 minutes. I want you all to tell me what the voltage across the 8 ohm resistor is. Do that for me. So Kestrel, Drew, Nikolai, Ryan, like all them now wake up or what? I don't think they wake up yet, you know. I feel like they come to class and they fall asleep again. Ryan, you awake?
Yes, sir.
Ryan, I see you joining really late. What's going on? Like, you forget to had class, or either that, or you probably wake up late. Which one is it? Wake up late, or you forget to have class?
Okay, I had class.
Please, boy. Kestrel, what about you?
I was sleeping, and then well, I just wake up just to just sleep, and I see how you saying wake up, and I was like, so I currently line up with my calculator watching class.
Oh, that's an interesting setup. So, You'll have 28 minutes again. I'm waiting for answer. Send me answer when you feel you get through. Okay, so the time is up. Did any of y'all get an answer? Ryan, Nikolai, Drew, Vanny, Jadon. Any of y'all get an answer?
.67.
0.67, I got?
Yeah.
Vanny, what about you? Kestrel, Ryan, Drew?
So I got 0.67.
Right, so Kestrel,
So I got a fraction and I got 2/3.
what is 2 over 3?
I do not know.
Nah, yeah, I don't know. Because I feel like that's something you will learn in SCA. Like, you know, when you're converting, I'm not sure what people still learn in SCA. But 2 over 3 is 0.67.
Okay.
Yeah. So let me explain how this works. So in the previous part, we calculated the current that's going to flow through the circuit. So this is our series circuit. So the same current is going to flow through every single component. So the current going through each component in this circuit, it was 0.08. Well, to be precise, is really 1.5 over 18. That's like the actual value. So here's what I'm saying. If we want to find the voltage across the 8 ohm component, we know that voltage is equal to current times resistance. So we want to find the voltage across the 8 ohm. So the current through that is 1.5 over 18. And the resistance is 8. So you see 1.5 over 18 by 8. And you should get 0.67 amps. Again, 67. What's in amps, boy? Sorry. Yeah, voltage. Now I want to show you all something really cool. Could anybody tell me what the source voltage is? The source voltage, like the voltage from the battery, is what I'm saying. The source voltage is like where it was like the total voltage for the whole circuit and where the circuit gets its current and voltage from. So what is providing power to this circuit?
The 1.5.
The 1.5 volt battery. So the voltage across the entire circuit is 1.5 volts. So what I want y'all to do for me, I want y'all to add 0.83 and 0.67 and tell me what you're getting. Do that for me.
1.5.
Fadi, did you get 1.5 when you added 0.83 and 0.67?
Yes, sir.
Right. And you notice that is the battery of the... I'm not saying... That is the voltage supplied by the what? Vanny, look at our circuit. That 1.5 pops up somewhere else. Where does it pop up?
By the battery.
Exactly. By the battery. Yeah. And you notice, Vanny, when you add the 0.83 and the 0.67, what do you get?
1.5.
Right, so I'm going to make a little statement here. So the sum, by the way, if you didn't know, across every resistor, you're going to have something called a voltage drop. So the sum of voltage drops across each component in a circuit is equal to the source voltage. And when I say source voltage, I mean what's the voltage across the battery? What's providing power? And so you will see that for yourself. So the battery was supplying a voltage of 1.5 volts. So the total potential difference across the circuit was 1.5 volts. And when you add up 0.83 and 0.67, what did we get? Somebody tell me. Right. So I hope you all understand what I'm saying. So some voltage is going to drop across the 8 ohm and some voltage is going to drop across the 10 ohm. The point I'm trying to make is that should give you 1.5 volts because that's the total potential difference. So there's another way you could have answered this question. Instead of doing that, you could have also just said what? Somebody try to figure it out. Instead of saying V is equal to IR, what could I have done to find 0.67? Let me see if you all could think. Guys, instead of using Ohm's law, how else could I have found the voltage across the 8 ohm resistor?
1.5 minus 0.83.
Yep. I could have just said 1.5 minus 0.83. And that would have given me 0.67 volts. That's another way you could have done it. Cool. Avani, do you feel like you understand it?
Yes, sir.
Alright. Jadon, Drew, Kestrel, Ryan.
Yes, sir.
Alright. Nikolai, what's going on?
Yes, sir.
Alright, so Nikolai, you go to the next question. What's going on? Alright, so Nikolai, what do they want us to calculate in this question?
You jump into the
Right, remind me, what does an ammeter measure?
amps,
Right, which is a measure of what?
watts,
Say that again?
watts.
You say watts?
Yeah, those watts. One.
Nah, ammeter measures current. Current. Not watts. Right? Ammeter measures current. So I want you to look at this circuit diagram and let me ask that question, Nikolai. Should the so you see how we have A1 and we have A2? Those are the ammeters. Now should our ammeter affect a circuit?
No.
No, these measuring devices, it should not affect the circuit at all. So what I want you to do, I want you to remove the ammeters from the circuit and just consider the circuit by itself. Because the ammeter, when you look at it in the circuit, it might confuse you. So just draw the circuit without the ammeter. Nikolai, if you had to say what kind of circuit is this, series or parallel?
Parallel.
This is a parallel circuit. Now, anytime you have more than one resistor, what you should probably do. Tamo Nikolai, if I have more than one resistor, what should I do? I'm not hearing you.
Nah.
You're sure or you're not sure?
For the current, you know?
No, not put the current in half. The current wouldn't always split evenly, you know. Right? You have to be very careful here. So guys, anytime you have more than one resistor, you need to combine the resistor. Okay? So when you look at this circuit, A1, I want you to tell me something. Which one of these... Wait, before I say that. What's gonna happen at this junction here, guys? What's gonna happen at that junction? Anybody can tell me? What's gonna happen at this... What's gonna happen to the current? It's going to split. So the current going through A2, is that the total current or is that like a portion of the total current?
Portion.
Do you all understand that or no? What I'm saying is, the current is going to split at this junction. So if the current splits at that junction, only a fraction of the current is going to pass through the 8 ohm resistor, not the total current. Right? At A1, what does A1 represent? A fraction of the current or the whole current? The total current, right? The total current? Yes. If you want to find total current, you first have to find total what, Nikolai?
Total resistance.
Right, so we need to find the simplified equivalent circuit. So you're seeing two resistors in parallel. So how am I going to combine those resistors?
Add them together.
Remember or not?
Nah, man.
Alright, does anybody remember how to combine resistors in parallel? Anybody?
Yes, sir.
How do you do that?
1 over 8 plus 1 over 10.
1 over 8 plus 1 over 10. That's all? There's more.
To the power negative 1.
Right, to the power negative 1. So, Nikolai, this is how you add resistors in parallel. So, you write 1 over the resistor plus 1 over the resistor in brackets to the power negative 1. So, Nikolai, plug that into your calculator and let me know what you get. Now, Nikolai, if I remember correctly, you have the Oxford or something calculator.
Yeah.
Right, you remember how to plug that in into your calculator or not?
Yeah, I think so. Real brackets.
I'll give it a try. Real brackets.
.125.
Nah. So let me show you how you're going to plug that in. So you're going to open a bracket, and that would represent this bracket over here. Then to put 1 over 8 into your calculator, you have to open another bracket. You're going to press 1 divided by 8, close bracket. Then you're going to say plus, and then you're going to put 1 over 10. We need brackets again. So you're going to say 1 divided by 10. You're going to close the bracket. And since you open a bracket on the outside there, well, you have to close the bracket on the outside. On the outside there as well. And then you're gonna press, like, it should have some extra power or something. You're gonna press that, then you should see like this pop up. Then you're gonna press in brackets -1, close brackets.
4.44.
Yeah, 4.44 is the answer you're supposed to get. Did anybody else get that?
Yes, sir.
4.44, right? Yeah, no, maybe.
Yeah.
Yes, sir.
So that's
Yes,
gonna
yes.
be 4.44 what? What's the unit for resistance?
Ohms?
Ohms, yeah. So instead of drawing this big circuit, what could I just draw instead? Oh wait,
Oh.
guys.
So what do you do with the resistance?
Yeah, I could just draw the circuit with one resistor. And that resistor would have a resistance of what?
4.44.
Right, 4.44. So what did I just do? Well, I just combined the two resistors together. So it's effectively 4.44 ohms. So here it is now. If I know what the voltage across the component is, and I know what the resistance is, what can I calculate? Come on, Nikolai. Nikolai, I have voltage and I have resistance. And the question was meant to find the reading on the ammeter, which is current. So, what formula I could use?
I can't remember.
Alright, so Nikolai, what formula has voltage, resistance, and current in it?
V equal IR.
Right, V is equal to IR, Ohm's law, as the name fit. So if we are using Ohm's law, and we want to find for current would be equal to what over what?
V over R.
Right, current would be equal to V over R. So the voltage across the resistor is 1.5 volts, and what is the resistance?
4.44.
So plug into your calculator and let me know the current you're getting.
0.33.
You get 0.33?
Yeah.
Anybody else can verify that?
That's right.
Alright. Now if you round that off to the nearest, well, if you say in two decimal places, that should really be 0.34, eh? Because it's 0.337. So that should be 0.3, that should be 0.34. Why? Because again, it's 0.337. Number after 37, so round up 0.34 amps. Now, Nikolai, do you think that would be the current reading for A1 or A2?
A1.
Why do you all think that would be the current reading for A1? Anybody can tell me? Could anybody tell me why is that the current reading for A1? Nikolai, Jaden, Kestrel, Drew, Shayna, Nikolai. Tell my guys, why is that the reading for A1?
Because the current never split yet.
Yeah, the current never splits as yet, so this represents the total current. And when you want to find the total current, you first have to find the total what?
Ohm.
You said ohm?
I mean resistance.
Right. If you want to find total current, guys, you first have to find total resistance. So to find total current, you need total resistance. So you need to combine all the resistors in the circuit, and you also need the total voltage. So in other words, you need the voltage across the whole circuit. Right? So voltage across whole circuit. Or you could just look at the source voltage. Right, so the total resistance and the source voltage, which is the voltage you get by there being a battery in the circuit. Right, so we've just found the answer for A1. So the answer for A1 is equal to 0.34 amps. Now this is the hard part. Now, when in the last class, when I was talking about the plans for this session, I would have mentioned current divider law. This is where current divider law comes into play. So we found the answer for A1. Let's try to find the answer for A2. All right. So Nikolai, you there?
Yeah.
Okay. All right. So cool. So Nikolai, remind me, how does current flow typically? From negative to positive, positive to negative, how?
Positive.
Right, and that's conventional flow of current. When the current reaches here, what's going to happen?
Split.
It's going to split. Then it's going to meet back at this point. It's going to merge. Could anybody tell me what the current I is over here? Anybody? Could you all tell me what the current is over here?
0.34.
Yeah, it's 0.34. Nikolai, did the current there split as yet?
No.
And if you all are confused, I am talking about here. Did the current split there as yet? Yes or no? No. So that's going to be the total current then. And we found total current to be 0.34 amps. So we know this. And that current self is going to be split here. Right. Okay, so I want you all as a class to collectively think. What would you all do in this scenario? Let me hear, like, what would you all do? Let me hear what you guys would do. Now, before I say anything, I'm just going to jog your memory a little bit. If you have a parallel circuit, guys, if you have a parallel circuit, does the current going through each component remain the same, or does it split?
Split.
Right, the current splits for sure. The current splits. Okay. The voltage across each component is different or is the same? Tell me guys, the voltage across each component, is it different or is it the same? Think of, okay, how is your house wired? Is your house wired in series or parallel? Do you all know?
Parallel.
Yeah, your house is wired in parallel. Why would you do that? Well, you do that so every single component in your house could receive the same 120 volts. So voltage across each component is the same. This is a very important one here. The voltage across each component is the same. And lastly, if one component fails, the circuit still works. Okay. So I want you all to read this for me again. And you'll see it for yourself. Read it for me again. Nikolai, read that.
Voltage across each component is the same.
Okay, look at this for yourself. Could any of you all tell me what the voltage across the 8 and the 10 ohm resistor is?
Oh boy.
All you see that for yourself, right? Watch, look at it again. What is the voltage across it?
1.5.
Are you seeing that or no? Only for you seeing that, rest of you all.
Yes, sir.
So I have a question.
Yes.
If I have 1.5 volts across here, alright, if I have 1.5 volts across there, then would that voltage be across the 8 ohm resistor, the 10 ohm resistor, or both?
Both.
Anybody else? That 1.5 volts, is it only across the 8 ohm or is it across both of them?
Both.
It's across both of them. Why? Because in a parallel circuit, the voltage across each component is the same, and I hope you can see it for yourself. Watch, like literally, look at it. Like, I hope you see what I mean. So, like, watch. The positive is connected here, and the negative is connected here. So, the voltage across each of them is the same 1.5 volts from the battery. So, tell me, if I want to find the current going through the 8 ohm resistor, how would I figure that out? I want to find the current going through the 8 ohm resistor. Do you all have any suggestions?
One point five over 8.
Say that again?
1.5 over 8.
Yes. Yes. Well, that's smart, boy. So here I was saying, right? The voltage across each of these components are going to be the same. It will be the same. So if I have the voltage and I have the resistance and I want to find current, what formula do I have to use?
I equals U R.
Exactly. Right? So if I want to find the current through the 8 ohm resistor, then we're going to use V is equal to IR. Nikolai, if I make I the subject of the formula, what would that be equal to?
U over R.
V over R. Nikolai, what's the voltage across the 8 ohm resistor?
1.5.
And what is the resistance of it?
0.34.
0.34. You sure? Someone, that's 0.34. That's resistance or current?
Oh my god. Like current.
Like current. So,
4.4 kilos.
say that again?
I think the resistance is 4.44.
Nah. We're looking at every single component separately now. So, we said the voltage across the two components was 1.5 volts. So, the voltage across them is 1.5 volts. What's the resistor here?
8.
8. So if I want to find the current through the 8 ohm resistor, and the resistance I'm looking at is 8 ohms, and I know the voltage across it is 1.5. So that's going to be 1.5 over 8. What's the answer for the current?
0.18.
You get 0.18? And I'll be 0.18 what? What do we measure current in?
Ampere.
Alright, so 0.18 amps. Now I have a question for you, Nicola, and I want you to get this correct. I feel like you could do it. How would I find the current through the 10 ohm resistor? Someone, Nikolai.
Then
Say that again.
10 ohms.
Just change the resistance to 10 ohms, you see?
Yeah, so the 8 just put the 10.
How come I'm not changing the voltage?
But the voltage across the whole thing is the same.
Exactly, the voltage across the whole thing is the same. And I'm going to end up with 0.15. You sure you round that off correctly? 1.5 over 8. I notice you have some rounding up errors. Look at that carefully. If I want to round it up to 2 decimal places, what that will be?
0.1, 0.1.
0.11. So the second decimal place is 8, and the number after 8 is 7. So what would you do?
Round it to 0.
0.19. Oh, okay. And here's something I want you to do. I want you to add 0.19 and 0.15 and tell me what you get. Everybody, add 0.19 and 0.35. 0.19 and 0.15 and tell me what you get.
Zero point three four.
0.34.
And you know what? We see that somewhere before, didn't we? Where did we see that? Anybody? Where did we see 0.34?
That is how much the current is.
That's the total current. So you all notice that the current would have split, yes. But if you add back the current, what is it going to give you again?
The total current.
Exactly. So that brings me to another point, right? You see how in the last part we saw that sum of voltage drops across each component is just the source voltage, like the voltage across the whole circuit. Well, if you all continue physics and maybe you're crazy and you want to do electrical engineering like me, you'll learn about Kirchhoff's voltage law. This is essentially Kirchhoff's voltage law, KVL, and what you're seeing here is essentially KCL. Right, so you're all seeing that, right? Like when you add 0.19 and 0.15, you get 0.34. Okay. Do you all understand that or no? Yeah or no? Like when you add it back, you're gonna get 0.34.
Yeah.
Alright, so let me write down the rule here. Right, so the current entering a circuit junction always equals the sum of the split currents leaving that junction. And you know what we call this? This is called Kirchhoff's current law. I'll spell it out for you all. Or the junction rule. You could just call it the junction rule. You could just say the junction rule, right? So that brings me to our second point. Hear this earlier. Instead of doing this, how could I have found the current through the 10 ohm resistor? Anybody want to tell me? Instead of saying 1.5 over 10, how else could you have found the current through the 10 ohm resistor? Come on, man. I could do this. Guys. I'm waiting. One of y'all could tell me the answer. Jaden, do you know?
No.
So you would have to subtract.
Yeah, that's all. Tell me what I'd have to subtract.
You would have to subtract zero. You have to subtract 0.19 from 0.34.
Correct. Jaden, you see it now?
Yeah.
0.34 minus 0.19. I know what I get. You get 0.15.
Yeah.
Yeah, you can explain that for me, Jaden? Jaden, now wait to explain that to me. How that working out?
Yeah. You might have seen the total current from the E2 resistor by total current.
No, but how it working? How that make sense?
Like the subtraction.
No, but how it makes sense though? Like why I could do that? Like, let's look at the circuit diagram. So, like, this
Yeah.
0.34, that's the what current?
The total current.
So, what happening over here?
It's splitting.
And when the currents that go moving away from the junction add merge back, what is supposed to give you?
0.34.
So, if you know the current through the 8 ohm resistor, would it be hard to figure out the current through the 10 ohm resistor?
No.
No, you just have to subtract. So, that's why she said that. And if you want to say it elegantly, this is what you would say. The current entering a circuit junction always equals the sum of the split currents leaving that junction. And that's Kirchhoff's current law. Again, you can learn about it more if you pursue your studies in electrical part of physics. And this KVL, this is Kirchhoff's voltage law. Right, so your answer for this question, they want you to find the current A2, which would should have been the current through the 8 ohm resistor. And so that answer for A2 is just 0.19 amps. So that's the answer for this question, A2. 0.19 amps. Okay. That's not the only way you could have answered the question, but did you all understand this method using Ohm's law?
Yes, sir.
Okay. There's another way you could answer the question using the current divider law. So let me show you that. Some of you all might just prefer to use Ohm's law, or some of you all might prefer to use the current divider law. Alright, so let me explain. Let's just say we had a circuit and the current splits at this junction. Let's see, so over here we have the total current, IT. Over here we have a resistor. And over here we have a resistor. All you understand? Let me just call this R1. Let me just call this R2. All you understand or no? Like, let me know what you with me. Can you all see that this is a parallel circuit or no?
Yes.
So look how simple this is, right? If I wanted to find I1, which is the current going through R1, so I'll call her I1. Look how simple it is, eh? This is the current divider law. I1 is just going to be equal to R2 all over R1 plus R2 multiplied by the total current. Now I know it looks complicated, but it's very straightforward. And we'll look at an example just now. Okay, so if that's I1, could anybody tell me how you potentially find I2? Anybody could tell me how you'd find I2? So if you didn't realize, it's essentially a fraction. So anytime current splits at a junction, a fraction of the total current goes through one of the resistors. That's the point of it. Now you're probably wondering, sir, well, if this is I1 you're finding for, why do you put R1 over R1 plus R2? You can see just now. But just notice like the opposite. So, Jaden, do you understand that at the junction, the current is going to, like, okay, the current that goes through each component after, it's going to be a fraction of the total current. What fraction exactly? R1 plus R2. That's going to be the total fraction. R1 plus R2.
Yeah.
So, Jaden, if this was how I found I1, how do you think I'll find I2?
R1 minus R2.
I mean, I think it meant to say IT minus I1.
Oh,
Which is the total current minus T1. I mean I1. If you know I1, you could find I2.
oh, yeah.
Yeah, you understand, right? But the other way you could do it, which is what I wanted to hear, you could just say R1. It's gonna be R1 all over R1 plus R2. By IT. Let me show you it's in action now. Let's just say we had a total current of 0.34 amps. I wonder where that come from. I wonder. Yeah, let's just say we had a total current of 0.34 amps. Okay? And we had an 8 ohm and a 10 ohm resistor. Again, I wonder where this example comes from. Who knows? Who knows? Guys, which resistor is bigger? A 8 ohm resistor or a 10 ohm resistor? Guys, why are we so dead for? Which one is bigger, 8 ohm or a 10 ohm resistor? I promise I'm not asking any rocket science questions. Like, which one bigger? Hey boy. I have a 8 ohm resistor and I have a 10 ohm resistor. Which one is bigger? Again, I promise I'm not asking any rocket science questions. It's simpler than you think. Like, it's real easy. Like, which one bigger, 8 or 10? 10. 10 is bigger. So, at this junction, what is going to happen to the total current? Anybody want to tell me?
Split.
It's going to split. But I want you all to answer me this. Where's more current? Okay, where's most of the current going to pass? Is it going to go through the smaller resistor or is it going to go through the bigger resistor?
Smaller resistor.
Do you all understand that or no? I'm saying more current will go through the smaller resistor. Ryan, Kestrel, Vani, Nikolai, Drew, Shina are saying more current will go through the smaller resistor. That makes sense or no? So, okay, Shina, would more current go through the 10 ohm or less current? Oh, I see Shina now joining back. Vani, would more current go through the 10 ohm or less current?
Less.
Okay, I was just testing you just to make sure it was paying attention. Right, so Vani,
Yes, sir.
R1 is less than R2. Did you see that?
Yes, sir.
So more current will flow through it. So let's think carefully here, Vani. Let's think. If we wanted to find, and we could call this I1 and we could call this I2. If I wanted to find I1, we know that, don't we know? So Vani, stay with me, right? So Vani, don't you know that the current is going to split at this junction? Do you know that?
Yes, sir.
And when it splits, isn't a fraction of current going to pass through each resistor, like a fraction of the total current?
Yes.
Right, what fraction exactly? Well, it's going to be over the sum of the individual resistors. So if I have a 8 and a 10 ohm, then it will be over 8 plus 10. You understand?
Yes, sir.
Now, we just talked about this. Tell me, Vani, is more current going to go through R1, or less current?
No.
More. So, should I use 8 or 10? Should I put 8 here or 10 here? Which one will be the bigger fraction?
10.
Exactly. So I would say 10 over 8 plus 10, and I would multiply that by the total current, because I just say, if the current is splitting, then each resistor gain a fraction of the total. So I would say 10 over 8 plus 10 multiplied by 0.34. When you do that, you are going to get 10 all over 18 by 0.34. You can plug that into the calculator and tell me what you get. Chat, what's going on?
0.188.
If you round that off to two decimal places, what would you get?
0.189.
Means 0.19.
Yeah, sorry.
That's right. And what's the unit for I1? Or current. What's the unit for current?
Ohms?
Nah, ohms is resistance. Ohms is resistance. What is current? Current is measured in what?
Amps.
So that'll be 0.19 amps. Good. So that's I1. Now I have a question. Let's continue on this path. So R1 was less than R2. Now R2 is more than R1. So will more current flow through it or less current?
Less.
Alright, so less current will flow through it. So if less, I remember, is a fraction of the total current, right? So we know that it's going to be over what? What is it going to be over? Talmavani is going to be
The
over.
total, so 8 plus 10.
Right. And since it's receiving the smaller fraction, even though, hear what, right? Even though we're dealing with I2, which is R2, does it make sense for me to put 10 here? Or does it make sense for me to put 8 here?
8.
Because it's receiving the smaller amount of current, right? The smaller fraction. Because it's a bigger resistor. And I multiply that by 0.34. And when I work that out, that's going to be 8 over 18 by 0.34. And what am I getting?
0.15.
Aren't those the same answers I got when I just used Ohm's law? 0.19, 0.15. Yeah, 0.19, 0.15. Yep. Same thing. So what do y'all prefer? Do y'all prefer to just use this, or like do y'all prefer to use just Ohm's law and done? What do y'all prefer? Current divider law or Ohm's law?
Ohm's law.
Ohm's law? Okay, no problem. Before we move on, I want to give you all an example to do for yourself using current divider law. I want to see if you all truly understand it. Alright, so I want you all, and let me just call this 1 amp. Yeah, I want you all to find the current flowing through R1 and R2. Go. And I want you to use the current divider law, specifically. I'm giving you all... Nah, 2 minutes was enough. I don't know why I give all the extra minutes. Go. 2 minutes. I want you to find the current I1 and I2. Find I1 and find I2 for me. Alright, so your time is up. Did you all get the answers?
Yes, sir.
Alright, what did you all...
Yes, sir.
How much current is going through the 5 ohm resistor?
0.33.
0.33. And how much is going through the second resistor?
0.67.
Did you all get that or no?
Yes, sir.
Yeah or no? If you didn't get that, tell me, it's fine. I'll show you what to do. I'll help you.
So I get so I get 0.67 for the 5 ohm resistor.
Yeah, you're supposed to get 0.67 for the 5 ohm resistor. If you'll... Okay, hear what, right? If you had said 0.33 over here and 0.67 over here, that's wrong. How much of y'all did that? How much of y'all did that? Be honest, it's fine. It's a mistake a lot of students make. Jadon, did you make that mistake? Because I think you had to tell me 0.33 first.
I
I'm sure.
think so.
Well, don't tell me you think so. Check it for man, let me know. Because I don't want you to make that mistake in the exam. Let me know where you.
Yeah, yeah, yeah.
Let me ask that question. That make any sense? Like, and I'm not shaming you logically. Think about it. This is the smaller resistor. Will more
No,
current go through the smaller resistor or less current?
no, I have it 0.67 over 0.67 complete resistor. For the 5 ohm resistor, 0.67 and 0.3 for the cap resistor.
Oh, for the 5 ohm it has 0.67 and for the other one it has 0.33?
Yeah.
Oh, that's correct then. That's correct. Now, let me do the question. Guys, if you didn't get 0.67 here, tell me no. Tell me no. We'll go through it together and I'll make sure you don't make a mistake again. It's not 0.67. For the 5 ohm. What's in? Sorry. If you have 0.33, that's wrong. Right? That's wrong. So, if any of you all had 0.33, tell me now. Ryan, Vanny, Nikolai, Kestrel, Drew, Shina. Did any of you all have 0.33 for the 5 ohm? Kestrel, Shina, Drew, Ryan, Nico. I never heard anybody but Kestrel. Let's work the question out. So Kestrel, if I want to find the current, through R1, which I call an I1, how would I do that?
Um,
Did you do the question?
um, no, sir.
How come?
So I was kind of confused and I was just waiting for it to, you know, get
I,
out.
you see how the spidey senses does work? I had a feeling something was up, So I call you. Alright. Kestrel, this is the total current, right?
Yes, sir.
When you reach this junction, what happens to the current?
It splits.
It splits. So the current through R1 is actually a fraction of the total current. What fraction exactly? Well, it'll be over. What do you think? What will it be over?
Mm,
Say that again?
it'd be about 2.
No, the current does not split evenly.
Oh,
It's gonna be over 5 plus 10,
okay. So first, oh,
right? So 15. And,
mm-hmm.
well, we finding a fraction of the total current, right? I should write the formula first. So, it's going to be. Now, this part might confuse you, right? Do you understand me trying to find the current through R1?
Mm-hmm.
Right, so I'll say R2 all over R1 plus R2, and I'll multiply that by the total current, because again, it's a fraction of the total current going through each resistor. You're probably saying, so why using R2 if it's R1? I'm not sure if you're thinking about that. Are you wondering that?
Yes.
Well, you go see.
Mm.
What's R2? What's R2?
R2 is 10,
And R1 plus R2, if I add up 5 and 10, what that will be?
15.
And the total current is 1, so I'll multiply that by 1. Let me ask that question. I1, that's the current through R1. Is R1 the bigger resistor or the smaller resistor?
The smaller resistor,
So will that receive the larger fraction or the smaller fraction of current?
the larger fraction.
Right, so if you put 5 over 15, that wouldn't make any sense, would it?
Oh, okay. Yeah.
So that's why we choose the 10. So 10 over 15, that would be the bigger fraction, and the smaller fraction would be what?
The smaller fraction will be the smaller fraction of current would be it wouldn't be the 10. Right.
Okay, so
5,
Kestrel, if we have 5 over what?
5 over 15.
Yeah, 5 over 15.
Okay.
So I hope you understand. So like when you use any current divider law, if you're trying to find the current through R1, you're gonna say R2 over the total. If you want to find the current through R2, you're gonna say R1 over the total. It's kind of like the inverse.
Okay.
And I hope you see why. Because look, R1 is a smaller resistor. So it will receive the larger fraction. So instead of saying 5 over 15, you know what we say? We say 10 over 15. Now 10 over 15 is 2 over 3, which is 0.67 amps. We measure current in amps, by the way.
Mm-hmm.
Now I2. What would the formula be for I2?
It, it will be R1 over R1 plus R2,
Right. And I multiply that by the total current.
which is 1.
I write in the formula first, but yes, that's correct. So in the other line, what we gonna say?
5 over 15 multiplied by 1.
And that will be 0.33 amps. Now, Kestrel, think about this logically. If the current is originally 1 amps, and then it splits here, and it joins back here, what do you think the current leaving the junction would be?
1 amps.
So, if I add up the individual if I add up the individual currents, what should I get?
1.
Do that for me.
Yeah, I got 1.
Right. So it making sense. So if you're using the current divider law, remember it's kind of like the opposite, right? If you want to find I1, you have to use R2. If you want to find I2, you have to use R1. You understand?
Yes, sir.
How about the rest of you all? Are you all okay?
Yes.
Ryan, Sheena, Drew, Nikolai, Jadon.
Yes, sir.
Alright, good. Let's move on. See if you all really understand anything. Help me do this question then. So I want you all. This question gonna be tough for you. But I want to give all some time to see if you can figure it out. Right. Take some time to figure out this question. I'm gonna give you all 3 minutes. This question is a bit tough. I want to see what you all are gonna do. Alright, Jaden, are you coming up with anything?
Find R2.
find it for R2. But R2 is given. R2 is 4 ohms.
I mean the voltage.
Oh, yeah. That's a smart move to make.
Yeah, send your answer.
Yeah, good job. Good job. That's it. That's it. Okay, what about the rest of you all? Did any of you all figure out the answer?
Yes, sir.
Alright, send me a picture of your work and then if you figured it out. Kestrel, Vani, Sheena, Drew. Going on, Vani, you were able to figure it out, this question?
Sir, I'm now trying to do it.
No, trying to do it.
All the time I was like drawing down the diagram.
Oh, okay. Drew, that wouldn't be the answer. Drew, think about it logically, right? Drew, I'll wait on mute. Will more current go through the smaller resistor or the bigger resistor? Tell me, Drew, where would more current go? Through the bigger resistor?
It's smaller resistor.
Right. So if 1.8 amps going through the smaller resistor, then would more current go through the 6 ohm or less current would go through the 6 ohms?
Less.
Right, so your answer.
I do some nonsense.
Your answer had to be less than 1.8. Yes, Shayna, that's correct.
Is 1.2.
Yeah, it's 1.2. I mean that they really the options kind of self-explanatory if you look at it. Like the only answer that makes sense right there is A. But I want to see the working though. Picking the answer is fine. We could figure out what the answer is, but I want to see the working. Okay, so the time is up. So Shina, you got through. Jadon, you got through. Ryan got through as well. Nice. Fanny, talk to me. You feel like you have ideas as to what to do, or you feel like you need some guidance?
Sir, I might need some guidance.
Alright. Before we do anything, just by looking at the options, which one do you think is the answer? By looking at the options, which one do you think is the answer?
A.
Say that again?
A.
A is the answer, right? For sure. Because if the smaller resistor... Okay, if a current of 1.8 amps is going through the smaller resistor, then obviously less current would have to go through the bigger resistor. Alright. Let's look at the actual working. Fanny, what kind of circuit is this?
Parallel.
Parallel. What do I know about the voltage in a parallel circuit? Let's look at the notes. What do we know about the voltage in a parallel circuit? Check this out.
Is the same?
Okay, and when you say it's the same, do you know what that means?
Like, is the fraction? Like,
Nah.
wait.
Alright. So voltage, you can think of voltage as the difference between 2 points. Look at this for yourself. Can you see that these two resistors are in parallel?
Yes, sir.
Right, these are in parallel. So this is the positive side of the battery. It connects here. And this is the negative side of the battery, and it connects here. What I want you to see for yourself is that it's the same difference. Okay, at 1.5 volts is across both of them components. Watch, 1.5 volts here, 1.5 volts here. Like across both of them is the same 1.5. And let me explain. Vani, what is the potential difference across the battery? Alright, so the potential difference across the battery is 1.5 volts. Between the positive and the negative terminal, 1.5 volts. And that's the potential difference you have across the whole circuit. So from across here to here, that entire thing is 1.5 volts. So, Vani, if I were to ask you what's the voltage across the 8 ohm resistor, you tell me 1.5 volts. What's the voltage across the 10 ohm resistor?
1.5 volts.
Exactly. So over here, I'm telling you that since we have a parallel circuit, then the potential difference across the both resistors are the same. The voltage is the same. So let me see if we can figure out anything with that information. So the voltage across each component is the same. Yeah. So Vani, see if you can figure out anything with that piece of information.
Also, we need to find the voltage. So we could use V is equal to IR and we could find it.
Yeah, we could use V is equal to IR, and I would find the voltage of what?
R1?
R1 and R2.
Yeah, sorry.
Because remember, for a parallel circuit, the voltage across each component is the same, exact same thing. So if you find the voltage for one, you find any voltage for the other one. So how am I going to find that voltage? And you know what I say, sorry, I'm saying it's fine. If I want to find voltage, how do I do that?
You have 1.8.
Right?
And R would be 4 because you're using R2.
Mm-hmm.
And let me look at it. You'll get 7.2 volts, and that will be the voltage for both R1 and R2.
Correct. See, that's good reasoning. So across both resistors, you're gonna have 0.2 volts. You know what that means? Here, what? Another question they could have asked you. What is the voltage? Okay, what is the voltage of the battery?
7.2.
Exactly, 7.2. That's a good question they could ask. What's the voltage across the battery? Right, 7.2. So question, if the voltage across R1 is 7.2 and your resistance is 6, how are we going to find the current?
Well, you could use the same from Ohm's law, and you could put the I is equal to V over R.
Alright, I is equal to V over R. The voltage is, what's the voltage?
7.2.
And the resistance is?
6.
Alright, so what answer are we getting?
$1.2 amps.
Badness. And that is why the answer is E. Alright, so I'm going to do one more question for the D and call that a D. The next class, I want to move on to AC, DC. I want to move on to AC, DC. I want to move on to diodes. And we'll see if we can do anything more. But the next thing we have to cover is electromagnetism, which just gives students a lot of problems. Lots and lots of problems. So we're nearly done with the syllabus, guys. After that, it's just grind questions. Grind questions. Okay, who want to help me with question 3? Any volunteers? Any brave people? Any sacrificial pawns? That sound kind of grim. Any volunteers? Any volunteers at all? You know what? Kestrel says she wants to help us with this. Kestrel. Yeah.
Okay.
Feel like Kestrel excited to do this question. Right. So Kestrel, they want us to calculate the readings on both ammeters. First of all, what does an ammeter measure?
Current.
Right, it measures current. Now, what? Okay, does an ammeter or a voltmeter affect a circuit?
No.
No. So if you want, and you find the ammeters looking a bit ugly, you could redraw the diagram without the ammeters in it. If you want.
Okay.
Because they're not supposed to affect anything with the circuit. Don't worry, the question a lot easier than you think. It's very straightforward. The question I give all you just now, that was a tricky question. This is not that hard. Gosh, man, good notes. Cooperate. Now this might look complicated because you might be asking yourself, wait boy, look at thing. That's plenty thing, boy. Plenty problems. Or you know the Cuban boy on TikTok? Or you know who that is? Anybody know who that is? Like you be like, plenty problem, my boy, plenty problem.
Yes.
Yeah, boy. Yeah. Alright. So Kestrel, in this question, they want us to find the readings on both ammeters. So here what I advise you to do, Kestrel. I would advise you to draw the path of current. So you can like see where you had to find that. When the current reaches this junction, Kestrel, what happen?
It splits.
Right, it splits. See how the current moving, right?
Mm-hmm.
Alright, cool. So the current at A1, would it be the total current or would it be like a fraction of the total current?
Total.
Anytime you have to find the total current, you need to combine all the resistors into one big one. That's what you need to do. To find total current, you're gonna collapse, you're gonna reduce your circuit as much as you can. So let's do that. So I have a 6 ohm resistor here. I have a 2 ohm resistor here. I have a 8 ohm. The last one is a 16 ohm. So Kestrel, anytime you see current splitting, there is a parallel circuit. If the same current follows the resistors, the same is a series circuit, right? Okay, so Kestrel, would you say that the 6 ohm and the 2 ohm resistors are in series?
Yeah.
Would you say that the 16 ohm and the 8 ohm resistors in parallel?
No.
They are in?
Series.
I was just making sure now, because you know students just agree with whatever I say. Like at time I asked a student, so the sky blue with nothing. No, I didn't say that. I asked him the sky is orange. He said yeah. Yeah. Things as I really had to like change up sometimes. So if you notice the same current is going through the 16 and the 8 ohm, so they are in series. So from this diagnosis we could see that the 6 ohm and the 2 ohm they are in series. And we could see that the 16 ohm and the 8 ohm also in series. If you have resistors in series, it's very simple to combine them. That not hard. You can figure out that one. For sure.
Right.
So let we combine those resistors that in series, and then we will move on to greater things. So
Right. So 6 plus 2 is 8. And then 16 plus 8 is 24.
big mathematician and thing, boy, big up, big up.
So use the calculator. But
Oh, never mind. I think we take it back. I take it back. So the circuit is going to be reduced to this. So the 6 ohm and the 2 ohm is going to combine and it's going to be just be a 8 ohm resistor. And that 16 and 8 ohm resistor going to combine to a what?
24 ohm resistor.
Gosh, man. Good notes like to play up, you know. I find like the more updates you add, the worse the app gets in. Don't
So you
understand.
paying for the premium thing?
Well, I had good notes for a long, long time. So I had bought it back in the day and they never make my buy it back. So I just had to pay a fixed fee of 30 US.
Okay.
So I had to pay a monthly subscription. If I had to pay a monthly subscription for this, I'm not using this. Actually, I kind of don't have a choice. I gotta use it anyways. Because all my notes on this. Alright. So, is anybody utterly confused by what happened?
No.
Jaden, Vanny, Zachary, Kestrel, Ryan, Shayna, like are they real confused or they like are they understand?
You understand, sir?
Like all that Zachary come real late, boy. Zachary, like wake up. Like you know open your eyes.
Yes, sir.
Hey boy. Like your father wake you up.
Yep.
I feel like one of these days your father will give you a little cocktail, you know, you get something. Be like you only missing class, Zachary, mom.
Yes, as I feel so too, sir.
I feel like your father is a man that don't play. Yeah. All right. So I already find you missing more classes than you typically do. So I don't know what that's about.
I saw this week up late today.
Ah. All right. So Kestrel, let me continue. So Kestrel, we boil it down to something real simple. The 8 and the 24 ohm resistors, what are they? They're in what?
Parallel.
Right. So how am I gonna combine them?
You would do R1. Wait. Oh, hold on. Right. So you would do 1/8 plus 1/24. So -1.
Mm-hmm.
Um, hold on.
2 plus 2 is 4. Minus 1 dash 3. Quick maths. Quick maths.
Right. And then I got 1/6.
You get one
And
of
then,
us.
well, that was before the -1. But currently, my calculator missing like symbols. So I honestly don't know where to find the -1 thing.
What do you mean missing symbols? What kind of calculator
Like
you have?
I get like it blur off and I don't know which is which.
What do you mean blur off? You got this on my picture. I real
Like it
confused.
just disappear and I don't know where to find stuff. So that was kind of slimmer down too.
It's on my picture. Let me see what's going on.
Well, okay. Hold on.
But you're supposed to get the answer of 6.
Right answer, I tried to write it over, but then I failed and I just the current state on my calculator.
Oh my days. But still, you don't have an excuse. All you had to do, you have press second function,
Right.
and you should see like a yellow x to the power minus 1 on top of one of the buttons. The button that real bad like
Oh
that, but I'm
yes,
looking.
yes. Wait, no.
Measure.
I seen it at the bottom, but I don't know if it's yeah. Oh,
Wait,
right. Okay. Show the class. Right. So the word. Okay, thanks.
You get through?
Oh yeah, and I guess 6.
Right. And it's simpler than it even simpler than you think, you know. Okay. All that to the power minus 1 means it's just gonna reciprocate. That's all it means. So if you have 1/6, flip that for me. Flip it.
Oh, it would be 6/1 and that would just be 6.
Right. So that's what the power -1 does. It just reciprocates it. Just flips it.
Okay.
Right, so the total resistance is 6 ohms. So I could boil down that whole complicated looking thing into a circuit with one resistor. Yeah?
Mm-hmm.
So that's just a resistor. That whole thing just boils down to a 6 ohm resistor. Nice. Would I be able to find the total current?
Yes. When
Gosh man, good notes, you're playing up. Playing up.
right, and you'd be able to find the total current because current is equal to V/R,
Yeah.
right? And then right. So you would have to put 9/6. And you would get 1.5
1.5 what?
amps.
Oh, right. So you would have just found the answer for E1 or E2?
A1.
Right. We're going good. We're going good. So E1 is equal to 1.5 amps. Let's see the circuit thing not that bad. Right, so we have A1 is 1.5 amps. Cool. Awesome source. Yeah. And now we want to find the current A2. Now let me ask you all something. In this branch over here, does the same current flow or a different current flow? Like, let me ask you that question. The current that goes through the 6 ohm and the current that goes through the 2 ohm, is it different or is it the same amount of current? Question, guys. The current going through the 6 ohm and the 2 ohms, is it the same or is it different? Guys, answer me. Like look at it. Like, does it split here or is the same current going through the 6 and the 2 ohm?
It's the same current going through it.
Exactly, it's the same current. Hopefully you can see that, right? Watch, look at the arrows.
Yes.
Passing through the 6 ohm, passing through the 2 ohm. Right. So the point I'm trying to make is, though that 6 and 2 ohm thing that will throw you off. So instead, what I want you to do, I want you to look at this diagram. This diagram will make a lot more sense for you. So let me explain that one more time. Fanny, if you look at this branch over here, the 6 and the 2 ohm resistors, they are in what?
Series.
Right, so just combine them, and the 16 ohm and the 8 ohm, they are in what?
Series.
Right, and you understand that in a series circuit, the same current goes through every single component.
Yes, sir.
You see enough for yourself, the same current going through the 6 and the 2 ohm. So this circuit is fine. So tell me, Vanny, what's the total current? Like, what is the current that leaves the battery? How much amps?
1.5.
Right, so 1.5 amps. And that 1.5 amps splits at this junction. So you want to use Ohm's law to do this or current divider law? The current divider law is a fraction thingy. You know, like
Current
R1. Sure, no problem. So you want to find the current at A2, which is through the 8 ohm resistor. So we could just probably call that A2 one time and done. So that'll be what over what? Remind me how the current divider law does work again.
R1 over R1 plus R2.
Now you have to be very careful. Since we don't really have any symbols, we should just plug in everything one time. I have a question. If I want to find the current through the 8 ohm resistor, am I going to say 8 all over 24 plus 8?
So you put 24.
Right, I put 24, not 8. So plug into your calculator and let me know what you get.
$1.125.
You get 1.825?
125.
1 point... Say that again?
Sorry, 1.125.
1.125? 1.125 is it?
Yes, sir.
And guys, if I wanted to find the current through this resistor, what would I do? Anybody?
So you would put 8 over 32 by 1.5.
Yep, that's correct. Right, and Jadon, I remember you saying that you preferred our Ohm's law, yeah?
Yes, sir.
So let me do it Ohm's law. What is the voltage across both of these resistors?
32.
How much?
What the voltage? Oh,
Yeah. What's the voltage across both of these resistors? In parallel, so they got the same voltage. So what's the voltage
Right.
across it?
9.
9. So we have 9 volts across these resistors. So that would, you know what it's going to be? So you have the voltage is 9 and you have the resistance as 8. So V over R, that will be 9 over 8. What's 9 over 8?
1.125.
Okay, same answer.
Yeah.
So honestly, I would probably stick to Ohm's law. Ohm's law is like real easy. Watch. Or using Ohm's law. Guys, if we use Ohm's law, you can see that we have the battery here. So the battery is going to provide us with a potential difference of 9. Since this is a parallel circuit, the voltage across each component is going to be the same. So the voltage across each component there is going to be 9 volts. So we have 9 volts across the 8 ohm resistor. So the current is just going to be V over R, which is 9 over 8, and that gives you 1.125. Vani, see how simple that was? It's crazy. So whichever way you want to do it, guys, will work. It's up to you. Cool. So I will send this immediately after class. Are they already document with every single note, like all the notes, like with that's like a 200 something page document, or you just want what we do in class?
So I'll take the one with all the notes.
Okay. Now, a large population, a large number of you guys did not do the homework. So, seeing that we like essentially done with circuits, I want you all to attempt these questions. Alright, this is your homework. You all should be in a better position in terms of circuit analysis. So I think you all should be able to answer these questions using the knowledge you have. That's my hope. Jadon, it sounds like you like circuit analysis.
Not so difficult, I know.
Right, so this is your homework, guys. Cool. So yeah, guys. Hope you all have a great Saturday. Take care, guys. Later.
Yes.
Bye, sir.
Another one, like all the notes, right?
Yes, sir.
Okay, no problem. Take care, guys.